Okay, folks, again, thank you for joining us. As we're getting more lines opened up, we'll get started. Again, thank you for coming over to this virtual session. We do these OpenSDX sessions on a quarterly basis, many of them on a monthly basis. We are super happy, again, to welcome Henry Balthazar from Forrester Research, Gaetan Kasline from VMware, and Bedard from Cox Communications. This is Tarkan Maynard at Nexenta, Chairman and CEO. And also a slew of folks on the system who are helping us on this webinar logistically. We are going to start with Henry, discuss the overall state of the industry in software-defined data center and software-defined storage, tying to virtualization and other workloads. Then our friend Gaetan Kasline from VMware is going to talk about some of the leading initiatives at VMware. And obviously, last but not least, our friend from Cox Communications, Bedard, is going to go through some of the amazing work they're working on around virtualization and software-defined data center, obviously working closely with companies like us, Nexenta, as well as VMware. From an Nexenta perspective, we're super happy to bring everybody in, and we had a tremendous response in our previous webinars, another one today. And this is being recorded for future audio follow-up, but also we're going to have a Q&A at the end. We're going to keep the slides to a minimum, even though Henry has some great content from Forrester Research. He's been doing a lot of work with us in the past. As Nexenta, we've been working with Henry and Forrester for a long time, and they've done very quality primary and secondary research, and also great vision documentations and strategies, talking to customers and partners like you. So with no further ado, Henry, you have the control of your slides, and look forward to your amazing content. I've seen a little bit the slides earlier, obviously. You have some fantastic content with some primary research. Virtual microphone is with you. Thank you, Henry.
Thanks so much, Tarkan, and thank you all for joining me today. As Tarkan said, my name is Henry Balthazar, Senior Analyst at Forrester. I've been covering storage for a better part of 18 years now, and I must say at this point, this is probably one of the most interesting points in storage. I think the reason why it's so interesting is not only because of the fantastic new technologies that are coming in, like software-defined storage and a lot of the flash technologies, but I think it's also very challenging because, at the core of it, I'm sure many of you that are IT managers already feel this, your customers are changing, your stakeholders are changing. Specifically, your stakeholders and customers are becoming less tolerant about waiting for resources. They're becoming less tolerant of downtime. And as a result, we all need to raise the bar in terms of the levels of services and the acceleration we can provide to get these services to stakeholders at the right amount of time, as quickly as possible, so they can derive business value for your company. In terms of the three biggest challenges we see in storage today, the first part's not really that new, but for many organizations, you're storing more data for every business operation, and as a result, data storage is still a major problem within many organizations. One of the caveats that are making things even more difficult is the fact that when we look at our budget data, which we'll be showing shortly, most budgets are not growing very rapidly and nowhere near the pace of data growth. So to me, that signals that we have to do things a little bit differently going forward. Another thing is business stakeholders, as I said, their requirements, their expectations for provisioning, they want to see things faster. One of the biggest reasons people go to cloud is because they have the belief that they can get their jobs done faster because they can get nearly instantaneous access to resource. When we look at some of the provisioning data and when we see what's out there in environments today, we definitely need to be faster with provisioning resources. And I think a big key to that is going to be what we wind up doing with software-defined storage and the next generation of storage management, and we'll be talking about that in depth in the second part of this presentation. Another key aspect, which I alluded to earlier, is the fact that more and more workloads are considered critical. Very few are considered non-critical. Most workloads today are either going to be mission critical or business critical. So organizations right now have very, very little tolerance for downtime or data loss. When I look at the inquiries that I do every year at Forrester, I probably do a couple hundred inquiries on the enterprise side. If customers asking me questions of how to fix, how to approach a particular technology, what they can do to improve their environments. And at this point, nearly a quarter of my inquiries today are related to software-defined storage. So it's really a huge topic for many customers, and it's definitely an area where people want to figure out how they can tap into this new innovation to accelerate their environments, and also bring a broader flexibility in terms of technology capabilities and the ability to deliver these in a very rapid manner. Another key thing that we're starting to see is there's also a lot more requests these days for performance, for customers that are looking to get higher performance out of their environments. So I think one of the main things I'm looking at here when I think about that is, as we go into much more broader virtualization type environments, as we start doing higher consolidation of hardware, we need to have, regardless of what we wind up doing, especially if we're looking at these new technologies, we need to have a high level of performance and high level of performance control to be able to service the workloads that are coming in an efficient manner. As I mentioned earlier, when we look at storage budgets, definitely some of the things that stand out to me is that for 40% of our enterprise respondents, their budgets are probably going to stay about the same, and actually for 7%, they're expecting to see a decline in their storage budgets. In contrast, when we look at the growth, most of the players are only going to get a very small amount of growth. So what we're expecting is to see relatively flat to slightly increasing budgets. That's bad news, because when I talk to most enterprises, on average, most of them are seeing at least 30% data growth rates in their environments. To me, what this says is we can't keep doing the same things we're doing today. We can't just keep throwing rigid appliances out there and expect the problem to go away. We need to start finding more flexible ways of dealing with data growth issues, and we need to be able to try to create a more sustainable environment. I think that freedom is going to come from software-defined storage and software-only storage, and we'll be talking about that in depth very soon. Another key aspect that I alluded to earlier was the performance aspect. Again, while virtualization is an awesome technology and it's a great tool for consolidating workloads onto a fewer number of physical devices, the thing is the workloads that get consolidated wind up creating a great performance pressure with the concurrency of these workloads on top of these shared resources. As a result, the difficult part is not only having lots and lots of these workloads on an array or lots of these workloads on a virtual NAS device. It's the fact that these workloads are constantly changing, whether it be some things could be ERP-like related or application related, where it's relatively high and steady utilization of performance. In some cases, it could be something like test and dev, where you see spikes of load and inactivity, which also wind up creating some havoc in the resources. So ultimately, when we try to talk to customers about this, we try to advise them that performance requirements are not going to be are rarely going to be static. You definitely need to start thinking about creating a storage architecture that can adapt to your needs. And also, probably the most important thing of all is you need to really spend more time talking with your stakeholders to get an understanding of what their workloads really require, from a performance perspective and also from a capacity perspective, because getting more knowledge there will allow you to pick the right technologies for their needs going forward and do less guessing and less, which should ultimately reduce the inefficiency in your environment. As I mentioned earlier, when we asked stakeholders about their applications and how they felt about them, only 29% of applications were considered non-critical applications. Those are things like test and dev. In general, the majority are either mission-critical or business-critical applications. Business-critical applications are very key applications. To me, are applications like some analytics, some reporting type tools, things like that. These are applications that if they go down, your business will continue to run, but it won't run anywhere near as efficient as it should be. In contrast, when we talk about mission-critical workloads, we think about things like the operations platform for a utility company. Really key applications that if they go down, you're not servicing your clients, and ultimately they're mission-critical because they knock your business out. In any case, if we start looking at these things and we start thinking about customer expectations, we need to start gearing our infrastructures to deal with these mission-critical and business-critical workloads. In this next slide, we did a follow-up regarding the survey in terms of getting a better feel for what customers were using to protect mission-critical versus non-critical workloads. And no surprise, we started seeing more synchronous replication and higher margin, much more resilient levels of data protection for mission-critical applications as opposed to non-critical, where very few people were using replication for that. They were usually using things like tape, or they were using periodic snapshots to be able to protect those things. But I think the key aspect here is no matter what you wind up doing in terms of your storage upgrades and innovation going forward, you definitely need to keep in mind the needs for data protection and those types of capabilities in the new architectures. By and large, today storage is not being outsourced. 36% are operating everything in-house. Only 16% are outsourcing things completely. So what this tells me is, regardless of all the talk about people moving to the cloud, things like that, we really believe it's going to be more of a hybrid cloud environment. So you're still going to have to do innovation on the on-prem side, and you definitely have to, whatever you wind up running on-prem, it has to be efficient, it has to be agile, and that to me is another sign that says we need to start thinking about things differently. We need to start building flexibility into our environments. With that, I'm going to start talking about software-defined storage and what we're expecting to see, how we're expecting this transition to turn about. At Forrester, the way I wrote the software-defined storage definition, the key aspects here is, it's an architecture that pulls together existing and new storage resources, and one of the key aspects is it allows developers and stakeholders to be able to access these storage resources without administrator intervention through APIs and service catalogs. So really, when I started looking at software-defined storage, one of the biggest gaps I saw was how long it takes to provision resources, and as a result, I think we need to start attacking that better, to be able to increase the satisfaction levels of customers. As far as software-defined storage goes, we see great interest in this technology, and only 80% of the survey respondents said that they're not interested at this point. In contrast, we already had about 32 respondents said that they already had implementations of software-defined storage and were already testing some of these components today. And a very large percentage of enterprises were also looking, to deploy this in. I think 36% here said they're planning to implement it fairly soon, while only 19% said that they're interested but didn't have any immediate plans for deploying. As far as when customers ask me, where do I see software-defined storage fitting? I think initially it's going to wind up going after some of the low-hanging fruit, in particular unstructured data storage. There's lots and lots of unstructured data storage in many environments, and that's the data set that's growing the largest. And to me, a lot of the offerings that are interesting on the table today are NAS and object storage type of software-defined storage, which are really good for scale-out, and they're really good for maintaining large data sets at economic prices. Another area which we're starting to see, and we'll talk about more when we talk about hyperconvergence, is VSA-based storage, where you're running a storage virtual machine on a hypervisor and leveraging DAS storage on that hypervisor to create virtual shared storage across multiple nodes. There's definitely been a rise in this, and many of the hyperconverged players today are using an architecture based on VSAs. Another area, ultimately, while we did talk about unstructured data storage and virtualization storage as the two top key areas, we do believe that systems of record and high-performance storage are also going to be huge markets in the future for software-defined storage. It's going to take a little bit longer for those to come about. I think there's strong appliances in those areas, but with commodity flash dropping in price and more CPU power being available on commodity platforms, we definitely believe as these technologies mature, more and more companies are going to feel comfortable about putting their mission-critical systems of records and high-performance workloads on top of software-defined storage. When we talk about software-defined storage and the key elements we need to have to be able to run these environments, there were really three things I identified that I think you have to create a modernized provisioning environment around software-defined storage. First, you need to have API-based provisioning to go and discover resources and be able to facilitate the creation of global catalogs so that you can help start to create self-service type catalogs which allow customers to access resources without intervention. I think another key aspect and a bit of a gap in the market today is the storage virtualization capability. Storage virtualization is very important to me because I think we need to be able to start moving workloads to different tiers across heterogeneous systems when resources are scarce. While it's great to put a very important database on an all-flash array or something that's expensive for performance purposes, if that application is not using those resources, we can't afford to just leave things sitting there. It makes more sense to be able to move something to a lower cost tier and leverage the performance so that other applications have an opportunity to take advantage of those performance capabilities. Another really strong capability that we need to have more of is storage QoS. Storage QoS to me is the ability to set thresholds in terms of IOPS and throughput performance for applications. And to me, the really important part about this is, again, as we're doing more and more consolidation, we need to avoid the noisy neighbor effect, whereby a single misbehaving app winds up hurting the performance and the experience of the other apps that may be sharing the same storage resource. When I look at storage today, I think one of the biggest issues I've seen over my 18 years covering storage is the storage industry doesn't solve problems in an easy manner. Whenever a new problem comes up, we wind up solving it with a brand new platform. And that to me winds up creating rigid silos and a lot of inefficiency in environments. If we look today, in many common environments, it's not uncommon to see 3, 4, even 5 different platforms of storage within a single company. And with these different platforms, you wind up having a lot of complexity, and as a result, it becomes much more difficult for storage administrators to place these workloads because you have a finite amount of capacity in each of these different silos. And as a result, administrators spend lots and lots of time just trying to figure out where to put workloads, and that's part of the bottleneck that makes customers unhappy about how long they have to wait for storage. In the first phase of software-defined storage, I think the number one focus should be about let's figure out how to simplify provisioning. We're not going to be able to rip and replace. We're going to have to try to find a way to make our existing resources work within this management paradigm. And again, I think over the last couple of years, it's been very evident that the established players are adding SDS functionality, and it's also very interesting that strong emerging companies such as our host Nexenta have created really strong capabilities as well to help accelerate the management of these resources and also to provide more flavors of storage to be able to deploy to meet the needs of customers going forward. To me, ultimately, in the first phase, we're going to start working towards removing the storage administrator from the provisioning loop and replacing them with something like an automated service catalog, which has the ability to broadcast to customers and applications what levels of storage, what storage resources they have at their disposal, and accelerate that provisioning so that's more in a matter of minutes instead of days, hours, weeks, or in some cases even months that we've heard in terms of how long it takes to provision storage. I think another key aspect of this is once we start going to more of these automated designs, the catalogs, it allows us to have more freedom on the back end to start introducing new levels of storage to broaden our platform. And I think that's where we're going to start seeing more and more software-defined storage pools where we're running commodity resources and creating virtual storage instances on the fly to be able to deal with new tasks and new workloads that are coming into the environment. This is really, obviously, this is a bit more complex than what we have today, but this is the step that we're going to be stuck in for at least a year or so as we start ramping up and start creating the automation around these technologies. To me, the ultimate phase of software-defined storage will happen when we start having the majority of our workloads in software-only storage. Software-only storage products are entering the market today. These are the products that run on commodity hardware and use storage software to create the storage capabilities on the fly. To me, I think we're already in a phase where we're going to start seeing a spending shift away from proprietary silos and more towards inexpensive commodity hardware. The complete transition may take years to accomplish, but I'm definitely more confident about this happening now, especially the way that the market's changing, and especially when you start seeing some of the revenue numbers and what's happening to established players. What this winds up look like in the future is, instead of having those rigid silos in place, we're going to buy more and more commodity resources being x86 processors, RAM, SSDs, and whatever else winds up coming in whatever else comes about in the solid-state storage landscape. As that starts ramping up, instead of being stuck with rigid silos, the power of software to me is the ability to create these instances on the fly and be able to service the customers as needs come. To me, the biggest power of software is the only middle ground we have between traditional storage appliances, which are extremely rigid, and when you deploy a storage appliance, you're basically stuck with that resource for 3 to 5 years. And the other extreme is cloud storage, where you have the ultimate flexibility in terms of pay-per-use and the ability to scale up and scale down. The only thing that comes close to fitting both of those worlds is software-only storage, because that allows us to create new models where we could have more scale-up and also the flexibility to change technologies without having to do a forklift upgrade. To me, another key area that's going to be very important for us going forward is also going to be hyperconvergence. Ultimately, I don't see any market where hyperconvergence is not going to impact it. Right now, the focus is primarily on the mid-range where we're seeing a lot of very strong and very capable hyperconverged environments, especially for virtualization type of scenarios. That seems to be where the market is today, but very soon we'll start seeing more high performance oriented hyperconvergence blocks where you're using flash at the most accelerated rate. Because at the end of the day, it's a physics issue. The fastest flash you'll ever have will be flash that's actually directly connected to CPUs, and as a result, I believe we'll see more and more of these designs where we have CPUs close to flash, and that's how we're going to be able to address low latency applications. On the other side of things, when you look at archiving, it's also physics driven, because when you think about it, nobody's going to want to move 400 terabytes of application data to an application, especially when many of these archive systems are basically x86 systems anyway. So to me, what we're also going to see in that area, for the areas of analytics and our longer-term storage, we're going to see more people integrating applications into them so you can do the application processing on top of the existing storage resources. To me, hyperconvergence, the big aspect about this, I'm not going to read the whole definition out to you, but it's an architecture that packages server, storage, and networking functions into modular units. That's really great because it allows you to deploy these things quickly, and also gives you facilities for scaling these up when need be. I think the most disruptive aspect of hyperconvergence isn't really the technology introduced, but the fact that it makes it easier to tap into technology capabilities. For example, instead of having to hire a SAN administrator to have replication, scale out, and snapshots and those things, hyperconvergence's power is the ability to give those capabilities to virtualization administrators. So ultimately, as I was saying, the main thing about hyperconvergence is the simplification of technology access. I think that's what's powerful about it, and I think this is why this market is going to take off relatively soon. Again, I think, as a final note, one of the things we look at, while appliances are still the favorite format for storage today, mostly because that's what we've been buying for decades, things are going to change. Software provides a lot more flexibility. Software provides a much more easier way of tapping into the potential of commodity hardware. And when I look at some of the cons in terms of hardware certification, interoperability challenges, those are things that are going to be ironed out with time, especially as more and more customers demand this, and as the integrators get to do a better job of standardizing hardware. And in terms of also, last couple points here, this is going to happen because when we ask customers about what they really want in terms of simplification and management, 94% of our respondents in the enterprise said that they have to have much more unified virtualization management tied with the storage management. A lot of these silos between servers and storage wind up becoming inefficient, and customers are not really patient about having these silos not functioning correctly. So we're going to have tighter management tools to allow more and more customers to be able to see what's going on in their environments rapidly. And clearly at this point, we're also seeing a very high level of interest for converged infrastructures where you're packaging a lot of these resources together and simplifying management. In terms of final recommendations for hyperconvergence and software, definitely it's a great time to start using and enhancing your flexibility with software in place of appliances. Automation is really going to be the key you're going to use to accelerate provisioning going forward. And I think ultimately what we're going to see is some more simplified architectures using converged infrastructures, hyperconvergence, and software-defined storage to start simplifying the architectures, making it faster to provision resources, and also to get more technology flexibility going forward. With that, thank you. I'm going to be turning over to the next presenter.
Henry, thank you so much. Again, this is Tarkan Maynard at Nexenta, CEO at Nexenta, and this was Henry Baltazar at Forrester to give an update on the state of software-defined data center as a whole, with a specific view on software-defined storage. I guess the key theme here, after this deep analysis with some primary research, which is great for us, Henry, thank you for this, is that this is not just a myth or hype. It's been happening. It's been brewing for a long time. Industry is going through a huge change, and who is better than Gaetan Castellan at VMware to talk about that as VMware, as they are the leaders on software-defined data center. They've been leaders for a long time, and obviously a proud partner of ours. and we are partners with it, of being a big partner to VMware ourselves as Nexenta. So with no further ado, Getan, a great presentation obviously from Henry. I know you know him, and you know some of the work they've done. Some of the slides, you should not be surprised. Software-defined data center, software-defined storage, hyper-converged as a function of it is becoming a big deal. All the primary research shows the same. And please tell us, and our ever-growing audience, by the way, and numbers are growing through Henry's presentation in our audience. Getan, if you can go through your vision, your strategy as the storage and availability lead for VMware globally. So Getan, virtual microphone is yours.
All right. Well, thanks a lot, Turkin. So I'm Getan Kastelijn from VMware. Very much in alignment with what Henry just talked about, I'm going to be presenting VMware software-defined storage and virtual SAN, which is our hyper-converged infrastructure product. Now, okay, I got the slides, thank you. The starting point for us is this vision of the software-defined data center. If you look back over time, we've done an amazing job with vSphere and ESX to solve the compute issue. So compute today is way more agile and dynamic than it was in the past. But at the same time, we've exposed a couple of new bottlenecks. We've exposed bottlenecks specifically on the networking side and the storage side. Networking and storage today will still mostly delivered from systems that were designed 10, 20, even 30 years ago, and really haven't kept up with the pace of change and the need for change in the data centers. And that's what we're setting out to solve with our vision for SDDC. We're doing to networking and storage what vSphere did to compute. And essentially what that means, a very similar vision to what Henry just talked about, it's about abstracting away your underlying physical resources, pooling them, and being able to dynamically provision networking and storage services on a per application and per VM basis dynamically. Right? And ultimately, that's going to lead to a fundamental change in operating model. Today, we're managing storage in a very infrastructure-centric way. We're managing LUNs, we're managing volumes. It's slow, it's static to manage and provision. We're going to flip that model on its head and really enable application-centric, VM-based automation using policies, right? So that once you set a policy for a VM, everything underneath is going to automatically get provisioned to meet that VM's requirement. So that's the vision for SDDC, and then ultimately we're going to extend that to, we are extending that to the public cloud with vCloud Air and the vCloud Air network to really enable this vision of the hybrid cloud. Now, if I double-click on SDDC, how do you go about building this SDDC? Because you still need infrastructure underneath. It's not enough to just have that layer of software. You still need something to be providing storage, networking, and compute capabilities. And there's multiple ways. Customers now have multiple options. Traditionally, you can go out and follow what we call the open systems approach. So you buy networking, you buy compute, you buy storage as individual physical components, you deploy them in your data center, and then you add this layer of SDDC. Another option is to buy converged infrastructure. So thinking here specifically about things like EMC, vBlock, Ohci converged systems. These are appliances or chassis where you have networking, storage, and compute that have been pre-integrated, but they're still delivered as different physical appliances. So you're still dealing with physical silos across all of those functions. Now, whether you do open systems or converged infrastructure, SDDC is going to help you make that infrastructure a lot more dynamic, right? By being able to provision networking, security services on the fly, or storage services on the fly. On the storage side specifically, virtual volumes introduces a virtual data plane that allows you to provision your storage services to any VM dynamically. And that's great. Now, there's also another option to build out this infrastructure, and it's what we call hyper-converged infrastructure, or HCI. And this is really about taking all of those data center functions, compute, networking, and storage, and delivering those through an industry standard x86 building block. So basically doing away with your physical silos and provisioning everything off of x86. And what that does for you is it really simplifies the infrastructure and takes this vision of SDDC to the next level by eliminating the physical silos. So if I dig a little bit deeper on hyperconverged infrastructure, so really how do you go about doing this? Well, you take an x86 node, and on that x86 node, you're provisioning vSphere, the hypervisor, and your storage and networking functionality is going to be provided a software running on the hypervisor, right? So you're taking the intelligence out of these dedicated physical appliances and deploying it as software on the hypervisor. And so essentially, what you get out of this is a much streamlined infrastructure, right? So you have one standard building block that you can scale your infrastructure on. You can scale dynamically. If you need more capacity, all you need to do is drop additional blocks, additional numbers of these common shared building blocks. You get great performance because, especially on the storage side, you've brought the data very close to the compute. And it's also very cost effective because now you're building everything on x86, and x86 is going to be much more cost effective than provisioning capacity on scale-up dedicated physical appliances, right? So we think a much more elegant way of building out that infrastructure. Now, on the VMware side, how do you do this? Well, you're going to need that x86 node, and then you're going to need vSphere, which is going to provide you with the hypervisor as well as basic networking capabilities. And really, the new capability here is virtual SAN. Virtual SAN is what allows you to take the storage function and converge that onto those same x86 nodes. So that's kind of the new shiny object in this overall picture. If I dig a little bit deeper on virtual SAN, what is it exactly? Well, it's what we call hyper-converged storage software, right? So this is software that is designed specifically to provide storage for VMs. That is the unique design point. What it does is it basically pulls HDDs and SSDs. So you're going to have direct attached HDDs and SSDs that are attached to your hypervisor nodes, the nodes running vSphere. Virtual SAN is software that is embedded in ESX. It's going to pool all of those HDDs and SSDs and present that capacity as a shared data store to vSphere on which you can run all of your VMs, right? And essentially what you're doing here is you're converging storage onto vSphere, and ultimately this is about making storage go away, right? And that really is the ultimate design objective for us, is to completely make storage disappear as a separate product. You no longer have a separate physical tier for your storage, but you also no longer have a separate storage product. There is no storage product to be provisioned, to be deployed, to be managed, to be patched and updated, because the storage functionality is baked into ESX, right? And so ultimately this is about simplicity, right? It's about deep integration with vSphere. It's about being able to automate storage management and about moving away from managing these LUNs and volumes and really introducing a new operating model into the data center. If I look at the use cases, what's virtual SAN being used for? Well, we introduced virtual SAN 5.5 about a year and a half ago. It was called 5.5, but essentially it was our 1.0 release. 5.5 was for alignment with the vSphere release naming. And at that point, because this was the first version of vSAN, we were a little bit careful with use cases, and we positioned virtual SAN for kind of tier 2 use cases, essentially things like VDI, disaster recovery, and test and dev. Now we introduced the second generation of virtual SAN, called virtual SAN 6.0. We introduced that about 6 months ago. And we've made tremendous improvements between 5.5 and 6.0. For example, on the performance side, you can now deliver up to 90,000 IOPS per node. That's a 4.5x jump from vSAN 5.5. We're also investing heavily on data services. So for example, with vSAN 6, you now get very high performance snaps and clones, where you can have a snap depth of 32 snaps while keeping the performance overhead to just a few percent. We also have things like rack awareness and fault domains. And so with these capabilities, with these improvements, we're now very confident that virtual SAN can be used to run the most demanding business critical applications. And so when we look at the use cases, it's really very horizontal. It's designed to be the best storage for VMs, we have enterprise class in mind when we're building virtual SAN. So enterprise class performance, scalability, stability, data services, and so on, right? So very horizontal from a use case standpoint. Now, I would say that typically we're having a lot of success on VDI because VDI has that dual need for very high performance and very attractive price point. But we are definitely seeing a lot of our customers expanding to things like databases and business applications. All right. What is the value prop? What are customers telling us about virtual SAN? What do they love about it? Well, it really comes down to three things. First and foremost, it's about simplicity. And I just mentioned this, but it really is about making storage go away. Virtual SAN can be installed in 2 clicks, right? It's the same process as ESX install, 2 additional clicks, and vSAN gets turned on. It's managed through the same UI that you use to manage vSphere, right? So through the vCenter web client. Everything is policy-driven, so there's no bottoms-up infrastructure management. Everything is application-centric, policy-driven, and it's fully integrated with the VMware stack, meaning that you have full interoperability between all of the vSphere features and virtual SAN. So it's really about that new operating model, the simplicity that vSAN brings to the table. That, I think, is the most important thing. Secondly, it's about very high performance. So essentially what we're doing here is we're bringing the data very close to the compute, right? The storage, the data is going to co-reside on those same x86 nodes that are being used to run your VMs. And we're using flash for caching, but now we also have an option where you can use flash for persistence with the all-flash model of vSAN. And so this is going to give you very high levels of IOPS. I mentioned this 90,000 IOPS per host. We have yet to run into a situation where that's not enough, right? So I think that's plenty of IOPS capacity for every use case that you could have out there. What the all-flash version gives you is also very consistent sub-millisecond response times, right? So I think that's really the value of all-flash. It's that consistency of response time. vSAN also scales very, very linearly. So you can start out with as little as 3 hosts and scale up to 64 hosts. And when you look at how we scale from a performance standpoint, it is almost perfect linear scaling from 3 to 64 hosts. So that's number 2, right? There's a very high level of performance. And then lastly, it's about TCO. And typically, we enable a TCO reduction when you do a comparison between a mid-tier array, mid-tier SAN or NAS, and virtual SAN. Typically, we enable about a 50% reduction in CapEx. And the way we do that is basically because we're riding x86 economics. Like buying a terabyte of storage on x86 is going to be a lot less expensive than buying a terabyte of storage on a scale-up dedicated storage appliance. Right? So a big reduction in CapEx. We also enable a significant reduction in OpEx because we're making the management model just so much simpler. That there's also a lot of time savings there. To give you a few examples, what are customers able to achieve? Well, here we have 3 customers, Union Hospital, and in this case it was really about the OpEx piece. Right? It was about reducing the time to manage storage, and they estimated that it took them 10 times less time to manage storage with virtual SAN than it did on their existing arrays. Kramer has really had a performance objective. They had an existing SAN that was not keeping up with I/O requirements, and they were getting hit with very high latencies, especially during peak times. And by introducing virtual SAN, they were able to guarantee sub-1 millisecond latency at any time during the day. And then finally, Oregon State University, and for them it was really about cost, and they were able to reduce the storage capex by 60%. So just a few typical examples of what we see in our customer base. Now, final slide here on vSAN. How do you go about building your vSAN infrastructure? We're all about giving customers choice. And so on vSAN, it's the same, right? We want to give customers as much choice as possible in building out their infrastructure. Henry was talking about these delivery models, right? Multiple delivery models for storage. You can have a pure software-based approach, or you can still buy an appliance. Well, we enable both of those models. If you want to go down the software-delivered storage, you can buy a virtual SAN ready node. A virtual SAN ready node is a pre-configured system. They're available from all of the major OEMs, HP, Dell, Lenovo, Cisco, and on and on. They've been pre-configured and optimized for vSAN, but you can go and customize them. If you want to add memory or add CPU or add some disks, those are all things that you can do. And you buy the system from the OEM, and then you buy the software from VMware. Right? You buy vSphere and vSAN licenses from VMware, and then you deploy them in your data center. So this is what we call the bring your own license model. It's not a pre-integrated system. It is an optimally configured box, but it doesn't come with the software on it. The second option is to really buy an appliance, buy an integrated system, and this is what we call the Evo family. Evo Rail is a fully pre-integrated and pre-configured appliance. It comes with the hardware, but also with vSphere and virtual SAN pre-installed on the box. It's ready to be deployed, and you can be up and running in less than 15 minutes. So here the design point is really about ease of use. And Evo also comes with additional software to manage the deployment, configuration, and lifecycle management of the appliance. So we're giving you both of these options, ultimate flexibility with the virtual SAN ready node model, or much simpler deployment model with the pre-integrated appliance Evo. All right, so that was virtual SAN, which now brings me to our relationship with Nexenta. And virtual SAN, as I mentioned, is storage that's designed for VMs. Right? We've optimized this for VMs. What we do not provide is native file access. But a lot of our customers would like to have file access on top of vSAN. There's many use cases, end-user files, application files, and so they're looking for a way to deliver that unified storage experience on top of vSAN. And this is where we have an awesome partnership with Nexenta, where Nexenta has built a great solution on top of vSAN to provide NFS and SMB network shares. And to go into a little bit more detail, essentially it's based on the ZFS file system, and it's going to give you NFS3, NFS4, and SMB file services. From a management standpoint, Nexenta has done a really good job of integrating management with the vSphere web client. And then you get a bunch of nice data services, compression, dedupe, snapshots, clones, and secure authentication through Active Directory and LDAP. So a feature-rich, very robust appliance, and very nicely integrated with the rest of the vSphere stack. And then in terms of use cases, what we see is VDI is an obvious use case. If you have end-user files and you need to provide end-user file shares, this is a great solution. Also, if you need application file access, lab and test and dev environments are a great fit, as well as disaster recovery targets. So a lot of different use cases, and a great solution to really complement what VMware has done from a virtual SAN standpoint. So that concludes my piece of the presentation. I will now hand it over to the next speaker.
So, Gaetan, thank you for covering all these pieces. Great slides, a lot of information. I'm sure a lot of folks are going to listen to recording here as well as reach out to you. And I know we have many, many sessions at VMworld coming up, jointly working on many labs together, a bunch of new products being released and announced. And first of all, I want to also thank you personally and your team on behalf of Nexenta team is helping our customers worldwide with an amazing solution, and our partnership helping customers across multiple protocols, specifically in this case with file services, which is critical obviously for many, many virtualization and cloud-centric workloads. So thank you for a passionate presentation. And I know, and for those folks on the call and others, I know a lot of partners on the call as well. As a matter of fact, I'm overseas right now. We have tremendous demand for VMware vSAN as well as Nexenta solutions. So having said all this, speaking of demand, we have our dear friend Phil Bedard from Cox Communications. And Phil is the principal design engineer. He's a guru in this space, done a lot of work with VMware, Nexenta, and other technologies. So he's going to go basically and not going to do a death by PowerPoint. He's going to be more visual through the cloud and going to talk about, without slides, about what they've done and what this company stands for. So Phil, virtual microphone is now with you after get 10.
Hi, thanks for the introduction there. So yeah, I just want to talk a bit about Cox. Sort of, I think most people are familiar with Cox. We're a large cable operator in the United States. We provide services to both residential and business customers in many markets across the U.S. I think a lot of the reasons for looking at kind of software-defined storage has been covered by the previous presenters. A lot of it makes a lot of sense to us as well as everyone else. I'd actually like to talk a bit about two use cases that we have currently where we're using software-defined storage, and it kind of ties in well with VMware because we're using VMware vSAN in those environments for the software-defined storage. Like I said, we have traditional data centers that are very large that use large VMware deployments with traditional storage. We still have those environments. They're probably not going to go away anytime soon. They're very stable for us, but we're always looking at ways to leverage kind of innovation and next generation technology. Software-defined storage is definitely part of that. One place where we've found a way to very well use vSAN and is when we deploy services into sort of what we call our regional data centers. When I say regional data center, generally these are not kind of your traditional full-blown data center. It could be a cable head end. It could be a very small data center located in a market. It doesn't really make a lot of sense in a lot of those environments to deploy kind of traditional storage appliances that are separate from the compute environment. So what we've done today is we've installed using just regular x86 commodity servers, vSAN clusters in those environments. They're clusters of 3 or 4 servers that give us basically highly available storage. That was one thing to touch upon as far as the vSAN angle is it is highly available storage. So without spending a lot of time and effort, it gives us that ability to have the shared storage pool between however many servers that we put in there. And it is all about kind of that converged infrastructure that's easy to manage. Now it is just one group that manages it because like Gaetan said, it's a very, very easy thing to spin up vSAN. So it's really just a couple of clicks once the boxes are plugged in, and you're pretty much good to go with it. So we use those in kind of these smaller data center environments, and it gives us sort of this scale out converged compute storage infrastructure that we didn't have before. It's very easy to add compute storage to the cluster as well. Storage is not tied to one specific node. It's like I said, it's highly available and easier to manage for us. The other place that we've recently kind of expanded this idea of kind of a hyper-converged compute storage environment is in kind of our network engineering labs. It's a place where we have a lot of very ad hoc needs for both storage and compute. I'm not sure how familiar people are on the call with things like NFV, network function virtualization, and kind of SDN technologies. It's more and more kind of x86 compute based and not so much dedicated, certain, network hardware based. So there's more and more use cases for, storage compute in our kind of network environments. And in testing a lot of these next generation technologies, we're having to do a lot in the lab that's, a little different from what network engineers traditionally did in the past. So what we've done in these networking environments now, in these lab environments, is build this shared compute storage infrastructure. And like I said, what it allows us to do is basically build it on commodity x86 hardware. We looked at using sort of traditional storage appliances for these needs, and to be honest, it was too much cost for the storage needs that we had. They also didn't have the agility to provision storage or the agility to expand storage in a manner that we required. So in the lab environment as well, we're using commodity Supermicro servers in this environment, and we're also leveraging vSphere with vSAN as well. And it basically allowed us to create this, today it's 150 terabyte, but it could expand to a petabyte very easily pool that various groups within a lab can use. Previously, the groups in our environment had different kind of siloed storage, compute, and that they managed on their own, which was very limiting overall. So now we have a shared, converged compute storage environment that's used by both security, business, backbone, metro, and CDN engineering groups at Cox. So vSAN really gave us the ability to create this storage pool very easily. I think, like I said, and vSAN touched on it, is how easy it is to provision storage with it. As long as the drives are laid out in the way that you need, it's only a few clicks to create it. I tested other various storage options, such as Ceph is popular these days, as well as kind of Red Hat GlusterFS. But to be honest, most of the people in the environment are not storage experts. And those types of technologies, while they work and are robust, they're not easy to manage at all at this point. And as far as adding things to them and changing things around, they just don't have sort of the agility that's needed kind of in this environment, and it's not as easy to manage. So, that vSAN pool gives us this kind of shared environment for VMs to use. But then comes in, we have lots of other servers in our environments that are not VMware servers. They may be bare metal servers running Linux. They may be Windows servers. They may be, other hosts running KVM or OpenStack. And that's where we leverage Nexenta Connect. And Nexenta Connect basically allows us to export the data or export, this shared pool of resources on the vSAN to any other host that may need it. And more often than not, we need file services off of, than sort of block storage for a lot of these things. They may be for, logging data. They may be for just, spinning up large numbers of instances in, say, on a bare metal KVM server, where we can now, better leverage, this NFS mount for even VM storage for another platform. Those are the things that kind of it allows for us. Nexenta Connect is very easy to provision new pools with. So it allows the end users themselves to go into vCenter, and within a few clicks, they can basically create a shared, a new pool for themselves off the shared infrastructure. And it's really kind of about, the agility that these technologies give us that we previously didn't have. And I try to, I'm more on the technical side of it, but, definitely the cost of the environment is probably a fraction of what it would have been in that kind of a traditional compute storage environment, which basically allows us to do, even more things with a sort of next generation technology. But that's basically all I had, was covering kind of our use cases. And I think the other presenters, they basically covered more of the whys better than I did, because there's a lot of good reasons these days to switch to more kind of the software-defined architecture in both the compute, storage, and network space, and leverage some of the commodity resources that are out there today versus the sort of siloed, vendor-locked-in solutions that we've had in the past.
Phil, thank you. Really appreciate it. This is Tarkan Maynard again at Nexenta. And we want to thank Henry Balthazar from Forrester, Getan Kestline from VMware, and now obviously Phil Bedard from Cox Communications for this great presentation, by the way, Phil. I really enjoyed it. And thank you for not killing us by PowerPoint. It was a phenomenal overview. And thanks also letting us know how you've been using VMware, vSAN, and Nexenta Connect to integrate the system throughout the architecture with other platforms and other protocols. So bottom line, we're getting some questions and emails as well, in addition to questions we got from the previous webinar. Hope we can get to a couple of these, but if you don't get to it, we will definitely share these things through our social media and the next webinar series, so if you can get the questions. But overall, from an Nexenta's perspective, obviously, we are in the open software defined storage space with an open source vision, as Phil mentioned in Cox Communications. There are tons of open source stories and ideas out there, but many of them really require very deep knowledge around storage and architecture, and deep types of workloads that our customers are battling with. Basically, in this case, Nexenta and VMware found a way as partnership to optimize and, most importantly, simplify storage management with the technologies we all use today. And on top of that, with open source technologies, again, from OpenStack to CloudStack to whatever that might be, integrated on a VMware platform, using the right Nexenta solution to give our customers an end-to-end open source collaborative software-defined storage solution, from block to file to object protocol, from one single pane of glass orchestration. So on that note, we have a few slides here, but I'm going to go through it very quickly. Without going through slides, I'm going to stop at this cover slide to continue the tradition of Phil from Cox Communications, not to go through many slides here. But overall, as Nexenta, our vision have been as a partner model based on our both scale-up system running on a ZFS file system for block and file, as well as our new solution we actually announced last year at VMworld, which is our Nexenta Edge object storage with still block interfaces and object interfaces with Swift and other interfaces like S3, delivering a scale-out capability, and via Nexenta Connect to make it easier for our customers to deploy storage pools and provision them and manage them with vSAN in the back end or whatever that might be for our customers to use. As we all know, all speakers talked about this agility. Any store is a big deal. Even VMware this year at VMworld, following on that theme around any cloud vision, and that is our vision as well as a big partner to VMware on any user, any app, any stack, any protocol, from block, file to object on any hardware environment. And that's the beauty of this. Our customers use Dell, HP, Cisco, they're using Quanta, Supermicro, and on any disk or flash on any type of cloud, working with the VMware vision and strategy, and obviously tying this to an open source collaborative platform at the end. We call this an open SDS, open source collaborative software defined storage, and we're going to announce some major new products at VMworld coming up later in late August. So on that note, we have actually not much time left, but there were a couple of questions. Maybe one I'm going to go ask in Henry. And Henry, there was a question, and I think you covered this, but maybe another opportunity for you to just very quickly to verify. I think folks on the call are interested on specific vertical industries and specifically workloads you're really seeing. I think you covered this, but maybe you tell the story one more time. Overall, where do you see the biggest verticals, and most importantly, workloads customers have to take a look at this for this type of solution, like VMware and Nexenta coming together? Can you touch on that very quickly, because that was, I think, the core of the story. And again, folks can find more information after the webinar on our website, VMware and Nexenta websites, as well as through social media. Henry, can you touch on that, the workloads and verticals one more time, even though you covered it already?
Sure, definitely. In terms of workloads, I think it's going to be, ultimately, it'll be very broad access. I usually suggest for customers to start with low-hanging fruit like unstructured data, because there's just so much of that in many environments, and it's growing at the most rapid out of all the workloads. Another key area where people want to use this is in virtualization workloads, because those workloads are also growing very rapidly as well, and the flexibility of commodity hardware is going to be very strong there. In terms of the vertical markets, a lot of my inquiries so far have been with service providers who are looking to deploy this immediately. They're well aligned with this because they've got chargeback and automation models, so software-defined storage becomes a nice plug-and-play element to add to them. In terms of other more traditional verticals, we've definitely gotten a lot of calls from financial services and insurance-type companies who are, they're traditionally using a lot of the expensive proprietary appliances, but they themselves also see a need to start broadening out and leveraging software-defined technologies to enhance their portfolios.
To add this, by the way, and we got those questions in the past. We saw some of these questions, but I'm also seeing some questions coming right now, and some of them are actually from some of the customers we just met today in the field as we were actually walking through overseas. Basically, talking about some of the workloads around archives and backup and recovery and home directories and file shares, some of the tier 2 type of implementations and workloads, and how it is easier and cheaper to use systems like ours and vSAN. So that was interesting, and I think Getan, you shared that also with test dev environments. This is interesting. Also VDI As a matter of fact, we just announced a big VDI service provider in the UK, VESC, basically claiming 1,200 days and 100% uptime, not 999, 79s or 99s, but 100% uptime using both VMware and Nexenta on commodity hardware using this. It's good. It's really great stories we're hearing. This is not a myth. So I want to thank the speakers one more time. There are a lot of new workloads and a lot of questions coming in as well. We don't have enough time. We're going to post them on our website. We're going to also social media that from both VMware and Nexenta. And again, at VMworld, upcoming VMworld, we have many announcements and labs working with Getan and Getan's team as Nexenta. And I know, Henry, you're going to be there, and a few other folks are going to be there. And obviously, Phil, we look forward to hosting you as well as Cox Communications. As we always say at Nexenta, it's all about 100% software, all about freedom and agility, and all about love. Our customers need more love, especially in the storage industry. A lot of love was lost in storage industry over the past 3 decades with a lot of difficult circumstances the customers were put in. And finally, democracy arrives, and dictatorships are going to move away. So we want to thank VMware and Cox and obviously Henry from Forrester to shed more light on this. So on that note, all love to all of you, and apologies that the time is gone, and we're going to share some of these questions on our website and social media, and we all see you guys and ladies and gentlemen in the next webinar coming up in the next month. Thank you for being part of this, and please watch out the next calendar item coming up near you. Thank you.